Hello everyone. Good evening to you all of you. From today onwards, I will start my physics videos. So I will continue from today. Okay. So don't forget to subscribe my channels. Okay. So my first topic for today is unit and measurement. Okay. So let's talk about the term unit and measurement. Okay. Unit is what something. Uh, Unit is what you can say. If I say, bring me one apple, apple remains same, but what is the quantity I'm telling you is what? One. So that is one unit, right? I'm specifying that one apple. Okay. If I say I have to travel 2 meter, 2 kilometer a distance, right? So 2 is the quantity, and what unit is what? In kilometer, right? Similarly, if I say I have to study for 2 hours, means 2 is the quantity, right? But what is the unit is hour. Okay. So this is how the unit and measurement helps us in our day-to-day life. Okay. So let us see. You know that physics is a quantitative science, right? Based on measurement and physical quantities. Certain physical quantities have been chosen as the fundamental and base quantity. Okay, all right. So there are some physical quantities. Physical quantity means you can say physically we are measuring, like let's say the length we are measuring, right? So we measure in meter. Similarly, mass is measured in kilogram. Similarly, time is measured in second. Temperature in Kelvin. Electric current in ampere. Luminous intensity in candela. And amount of substance is in mole. Okay. All right. So these are basically the physical quantity, as well as you can say the fundamental or base quantities also. But what is the difference between base quantities and fundamental quantities? See, fundamental quantities, actually uh, we have only 7 fundamental quantities, right? Which has a certain base, right? So each base quantity is defined as the terms of a certain basic arbitrary chosen but properly standardized reference is called unit. Okay. So okay, so these are the base quantity and fundamental quantities. Okay. If I move on further, so let's say derived quantities. What can be the derived quantities? So actually, derived quantity is as the name suggests, that derived means it can be derived from what fundamental quantities or base quantities. Let's say for measuring the area. So for measuring the area, what we need? Length, right? What is the unit of length? Is meter. Okay. So if I say a square has four side. Okay. If four side, if I talk about their area, so square has area is what? Side into side. If we do side into side, meter into meter, it becomes meter square. So the meter square is the derived units, and meter is the base unit, right? So let's see. This is the same thing which is written over here for volume as well as density also. Okay. But there are certain international system of units, right? International system, why we say? Because in this system, the worldwide the units are what accepted, sorry, accepted. Okay, so let's say kilogram is accepted worldwide. Okay, so let's see, there are basically four types of international system of units, right? CGS, FPS, MKS, SA, right? CGS is what? C for centimeter, G for what? G for gram, and S for second. Similarly, F for foot, P for pound, S for second, M for M for meter, K for kilogram, S for second. Okay, so this is basically the unit of what? Length, mass, and time. Length, mass, and time. So the derived unit is always written in length, mass, and time. Okay, so if I talk about the derived unit of, let's say, uh, length, so for length, uh, what for length, it has a meter, so you can say L1. There's no mass, so M0. There's no time, so T0. M1, L1, M0, and T0. This is what the diameter of, you can say, length. Okay, so all right, there are some special fundamental quantities, you can say plane angle and solid angle. So what is the unit of plane angle? Is radian, and solid angle is straight radian. Okay, so let us see what those are. They are the, you can say, special one. Okay, so this you can see as the plane angle, right? And solid angle. Solid angle is what? The 3D structure, solid shape, right? But plane angle has a 2D structure. Okay, as you can see, the d theta is the angle formed at the center, and ds is the what? The arc. Okay, you can say small area. R is the radius. Okay, so if I talk about the angle to find out that the minor angle, that is d theta, small angle, so d theta must be equals to what? The ratios of ds, small area, by radius. Okay, similarly for the solid angle, you can see d omega. D omega is equals to the dA by r square. Okay, why r square? Because you know that it's a solid angle, right? Now moving on next. So measurement of length. Okay, so measurement of length has a defined range, right? So there are some measuring devices that which we use in day-to-day life. For example, let's say meter scale. So meter scale has a 10 to the power minus 3 meter to 10 square, I mean 100 meter, right? We can measure with the meter scale. But whereas if the length is in very, you can say less, you can say in negative, means less than meter, so that is what we use the device as vernier caliper. Similarly, there's another device called screw gauge. Another one is a spirometer. Okay, so these are the different devices measure the length in day-to-day life. All right, so why we need these you can say scale. Okay, let's talk about, you know that size of the proton is what? 10 to the power minus 15 meter. Similarly, size of atomic nucleus is what? 10 to the power minus 14. Again, length of the typical virus is what? 10 to the power minus 8. Whereas the wavelength of the light is 10 to the power minus 7, and thickness of the paper can be 10 to the power minus 5. Okay, minus 4. Okay, so as you can see, these are the very small tiny object which has a length is very what you can say magnified. So can we use this measuring tape, meter, scale, vernier caliper to measure this? No, it is not possible for that. Okay, so okay, these are the different again the length. Again, if we talk about the height of the Everest, it is 10 to the power 4. Okay, radius of the Earth is 10 to the power 10 to the power 7. Again, these are the long distances. Earlier you can see these are the small distance, a small length, you can say a small length, or okay, and these are the long length or long distances. Okay, so you can see over here the distance to the observer universe boundary is 10 to the power 26. Okay, so let us see how we can measure large distance object. Okay, large distance, you can say the length of the, what you can say, earth to moon, okay, or earth to sun, etc. So for that, to measure the large distances, we use a method called parallax. Parallax is a displacement or difference in the apparent position of an object viewing to the two point, you can say viewpoint A, viewpoint B. There's a differences. The differences between the viewpoint A and viewpoint B is known as parallax. Okay, and distance between the two viewpoint is called basis. Distance between two viewpoint is known as basis. Okay, all right. Again, let's say S is the position of the planet and D is the distance from the two viewpoint or observer. Okay, D is the distance, observer A, observer B. Okay, there are 2 points. Theta is the parallax or parallatic angle, you can say, right? So for that you can say B equals to, sorry, it's, where is B? So angular size. Okay, if we talk about the angular size, if you find, so A equals to D by D. Okay, similarly, since we know that the planets are far away, so we can say that the b by d must be less than 1 also. Hence AB is taken as a arc of length B and D is the radius with the center S. So B equals to d theta. B equals to d theta. Alright. So similarly, if we have to find the angular size, so angular size is equals to the diameter of the planet, okay, and what distance between the what opposite points as it is viewed. Okay, all right. Now measurement of smaller distances, as we have seen the larger distance, now we will see the measurement of the smaller distances. So there are some steps how we can figure out the measurement of small distances. Okay, so these are the following steps you can follow to find out the size of the molecule. Dissolve 1 centimeter cube of oleic acid in alcohol to make a solution of 20 centimeter cube. Okay, so sprinkle lycopodium powder on the surface of the water. Okay, the oleic acid in the solution will spread over the water in circular molecular thick film. Measure the diameter of ever circular film using below calculation. Okay, if n is the number of drops of the solution in water, b is the volume of each drop, and t is the thickness of the film, and a is the area of a film, so total volume of n drop is what? N times b centimeter cube. Amount of oleic acid is what? N times b into 1 by the area, 20 into 20. Okay, this is the concentration of the oleic acid, how much oleic acid is present. So and thickness is what? T. So thickness equals to the volume of the film upon area of the film. Okay, I hope you get this. So this way you understand that how we can measure the large distances, how we can measure the small distances. So let us see some specific length units. So uh, the unit name is Fermi, which has a symbol small f, has a value 10 to the power minus 15 meter. Angstrom has a 10 to the power minus 10, represented by a upper dot. Astronomical unit is AU, which has a metric value is what, 1.5 into 10 to the power 11, or you can say 1.496. Light year distances. Okay, so light is what, the distance traveled by light in 1 year, this with the velocity of speed. Okay, distance traveled by light in 1 year, that's called light year. And the value of the meter, I mean length, is what, 9.546 into 10 to the power 11. Similarly, parsec is represented by pc. The parsec is the distance in which average radius of Earth orbit sustain an angle of one arc. Okay, that is the value of 3.08 into 10 to the power 16 meter. Okay. So here are the measurement of the mass. Okay, measurement of the mass is what? Let's see. So mass is usually measured in the kilogram, that we all know, but atom and molecules has a unified atomic mass is used. Okay. So one unified atomic mass is what? 1 U equals to 1 by 12th of mass of atom of carbon 12 isotopes. Okay, that is the mass of electron, 1.66 into 10 to the power minus 27. Apart from using balances for normal weight, mass of the planet is measured by gravitational method. Mass of the atomic particle are measured by mass spectrograph. Okay, all right, so these are the, you can say, the range of the mass. Electron has 10 to the power minus 30, proton has 27, red blood has minus 13, dust particle has minus 9, and red drop has minus 6. Okay, so these are the different things, you can remember this. Okay, all right, now let us see the measurement of the time. Time is measured using a clock, as a standard of time is now used. Okay, which is measured by cesium or atomic clock. Cesium or atomic clock is the unit of time actually. Okay, in cesium clock, a second is equal to 919263177 vibration of a radiation from transition between two hyperfine level of cesium 133 atom. Okay, so you can imagine how many vibrations are there in 1 second can be produced by a radiation. Okay, now cesium clock works on the vibration of the cesium atom, which is similar to the vibration of balances. Okay, national standard time or frequency is maintained by 4 atomic clock. All right, so an Indian standard time, IST, which you call IST, everywhere you can find it, is maintained by actually cesium clock only at NPL, National Physical Laboratory at Delhi. Okay, IST is mentioned by cesium clock only. Cesium clock are very accurate and the uncertainty is very low. 1 part in 10 to the power 13, which means not more than 3 microseconds. Okay, so you can remember this point, this is very important. Now these are the range of time. Okay, lifespan of unstable particle is 10 to the power minus 30, 24, etc. So thank you so much, we will continue.